Welcome to the FCP Fortigate Administrator series. This is topic 1.1, Network Settings. In this video, we're going to create etherchannel interfaces from our access layer switches, the core and the firewalls. We'll create layer 2 VLANs on our switched infrastructure and layer 3 VLAN interfaces on the Fortigate. We're also going to configure DHCP services. I'll show you how the firewall can be both the DHCP server and DHCP client at the same time. And furthermore, we can see that our internet connection isn't directly connected to the firewall. It's connected instead to the core switch on Ethernet 00. Therefore, we're going to be relying heavily on VLANs to get end-to-end connectivity working. And my approach in this video is to take a bottoms-up approach, meaning we're going to start from access switch 01 and make our way up through the stack to the core switch and then to the firewall, and then test everything else. That's access switch 01, and then configure the two VLANs, VLAN 200 and VLAN 210. Now sales. Now let's configure our trunk interfaces in a pod channel. And throughout this lab, we're going to be using a static ether channel config simply because it's easier and more reliable to depend on the static ether channels instead of LSCP. Our interface range is E00 and E01, and I'm going to create port group number 1. Then we're going to turn into our port channel 1 interface itself, and then give that a description. That's a logical interface. Give it a description, logical link to core. First, we want to configure it as a switch port trunk encapsulation .1q, and then define the switch port mode as trunk. Also issue a no shut command. And now let's review. We have our two physical member interfaces, and they're in the trunking state, they're in the connected state. And we have our logical interface, which is etherchannel port number 1. It's also in the trunking state. Everything so far looks great. The next thing I want to do is to join these two interfaces for PC1 and PC2, join them in their respective VLANs as access ports. Let's review one more time. That looks much better. The interface descriptions really do help. From here, you can tell. Oh, and I'm picking up that our trunk interface has gone into an error disabled state. And this is probably a spanning tree function. And because we haven't made any configurations on the core switch, there'll be a little bit of clashes there. So let's maybe, before we fix this, let's move on to the core switch and then create those interfaces before we can fix the issue. The first thing I'll do is give it a host name and then create the VLANs. And the other thing with the core switch, because we did say that the internet connection is coming into the core switch, we need to define the VLAN for internet connectivity. So we'll just make that VLAN 999. It can be anything. It doesn't have to be 999. Now for our interface configs, starting with etherchannel port 1. E10 and E11. And now let's turn to our port channel 1. Switch port mode trunk. It's always important to define your interface as a layer 2 switch port. Otherwise, sometimes you do come across issues where the interface defaults to layer 3, and you need to explicitly specify that it's a layer 2 interface. And now let's move on to create the ether channel port 2. The range there is E01 and E02. And since we're in the physical interface configuration mode, we give those a proper description. And then we issue the no shut command to bring our port channel 2 online. And now we turn on to port channel 2 to configure that one. And now next we configure Ethernet E00 into VLAN 999. Issue the no shut command. Now let's review our interface status. And looking at this output, we can see everything looks okay. Everything looks healthy. I think we have our connectivity in place. Now we do have an issue with access switch 1, which I believe now is the right time to address. We go into port channel 1, we issue the shut and no shut command. This basically resets the interface and its interface members. And now let's review again. And now it looks healthy. It's out of the error disable state. I believe we can proceed onto the firewall now. When you bring up a Fortigate online for the first time, you are required, or rather you are forced to set a new password, and that's exactly what's happening right now. All right, so on the firewall, currently I have a management interface port 1 connected directly, and this is how we're going to be managing the firewall when we connect via the GUI. In fact, if we list the IP addresses for this firewall, we'll see that the management interface already has an IP address. But we're not going to be using the GUI at the moment, and so we're going to create an aggregate interface connecting to the core switch as well as a VLAN interface for internet access, and then the rest of the configs we'll do from the GUI. So now we're creating our aggregate interface, and I'm just going to call it aggregate 01. There's a couple of things that are mandatory to get the aggregate interface working. Firstly, of course, you give it a name. The next thing we'll do is associate this interface with the root VLAN. Now let's define that it is of a type aggregate. As we can see, we have VLAN, aggregate, redundant, loopback, and so forth. So we have to specify that we're trying to create an aggregate interface. Next, we have to specify our interface members. And right now we know that we said our members would be port 2 and port 3. On the core switch, our ether channel is a static ether channel. That's exactly what we have to do on the firewall as well. Set LACP mode. There's a couple of options there, static, passive, or active. We're using static. Now let's review our config. We've associated to the root VDOM. We've defined the type aggregate, and we've specified the members, and we've specified the LACP config mode. That's all you need to get the aggregate interface working on the Fortigate. The next thing is to create our VLAN interface, VLAN 999. Following on the same logic, we have to associate this interface with our root VDOM. And here too, we have to specify the type of interface. In this case, it's going to be VLAN. And since it's a VLAN, let's go straight ahead and give it a VLAN ID. That's 999. And while we edit, let's specify the VLAN protocol. That will be 802.1q. Now this VLAN interface has to be associated with our trunk. And our trunk interface is aggregate 01, the one that we just created. All the VLANs will be associated with this interface. And the next thing that I want to do is to define how the IP address is going to be allocated to this interface. Are we going to manually assign an IP address to this interface, or are we going to let the firewall acquire an IP address from DHCP? In this case, I want the firewall, this interface, to get an IP address from the DHCP server from our home network. So we set mode to DHCP, and the local in traffic allowed will just be ping. I'm just only going to allow ping to this interface. Now let's review our interface config, and everything looks great. So now if everything works well, we know that our management interface has an IP address. And now that we've just created our VLAN 999 interface on the firewall, and it's a DHCP client, I'm expecting that it also has an IP address now from my home network. So let's check that out. And indeed, our interface 999 iNet also has an IP address. And from here on, let's move on to the GUI and complete the rest of the configs from the GUI. And already we know the FortiLink interface, we're not going to use this, or it's not part of our lab series. So we're going to disable this. Port 1 is not in use at the moment. We're going to disable that as well. Now let's review our management interface. I'm going to give it a nickname, just MGMT. And because we want for this interface to be dedicated to management, this setting over here is correct. What I'll do is specify my home network subnet where I'm going to be coming from. I'll make that a /24, or rather, let me be precise, make that /22. And I want this to be an interface dedicated to management. That means I don't want to retrieve the default gateway from the DHCP, because then it means the firewall will be using the management interface to try and forward pass-through traffic, which is not what we want. So this looks okay to me. That's all I'm going to change, and then just say okay. Now let's move on and have a look at our interface that we just created, the iNet interface to the internet. It got an IP address via DHCP, and I'm going to leave this the way it is. And it is retrieving the default gateway from the server. So if we look at the route table, we can see that we have a default route that points to VLAN 999 iNet. This is correct. This is why I removed the management interface, that setting from the management interface that said retrieve the default gateway from the DHCP server. This is more correct. And the only thing that I'm going to do here, just put the same alias as the name. The next thing we're going to do is to create the two VLANs, VLAN 200 and VLAN 210. We're also going to create DHCP services in these VLANs so that PC1 and PC2 can acquire the IP config dynamically and be able to communicate on the network. The first one would be 200 finance, associated with our aggregate interface, VLAN 200. And we're using the last IP address in the subnet. And you'll notice as well that by default, the firewall is going to create an address object representing the subnet. So you have an option to either disable that and create the address object yourself, but I'm just going to leave it enabled because I'm okay with the name. And the other thing that I want to enable is ping, because I want any device in the subnet to be able to reach and ping the firewall as their default gateway, just to test the basic reachability. We did say that we're going to create DHCP services for the both VLANs, and my DHCP scope will start from .100, and I'm going to leave everything just the way it is. Now let's create the second VLAN. Also associating that with aggregate 01, VLAN ID 210. The IP address there would be 192.168.210.254/24. Once again, I'm going to let the firewall create an address object for the subnet, and I'm going to allow ping to this interface and enable DHCP server. have the scope start from .100 and leave it there. So what I like to do is customize this view a little bit and remove some of the columns that don't really add value. So what I'm going to do is remove reference. I don't necessarily care too much about the reference or the DHCP range. I want to know about the DHCP client and the administrative access. And the other thing that I want to know is the VLAN ID associated, as well as the zone that any of the interfaces belongs to. And speaking of the zones, we know that the firewall sits at a perimeter, isolating your internal trusted network from the external untrusted networks, being the internet. So creating security zones simplifies your security policy and firewall management. So let's now create the security zones and associate them with the correct interfaces. Create new zone, and this one I'm just going to call trust. And the interface members for this trust zone would be the internal networks. And then create another zone. We call this one untrust. And we're just going to add our internet interface. And now at a glance, you can see your interface names. You can see the type of interfaces they are and the members. We can see our subnets and what local end traffic is allowed. And we can see the DHCP clients if you've got DHCP services enabled, as well as the VLAN IDs and the zones that each interface belongs to. And speaking of DHCP clients, our DHCP service is running, but we don't see anything here. Now let's move on to request our DHCP config from PC1 and PC2 and then come back and see what happens. So on PC1, we open terminal and issue the command IP address, and it has an IP address 192.168.4.1.1.1. Okay, this is not what we expected. Let's maybe look at PC2. Also, it has an IP address, but this is not an address range that we expected. Now let's maybe have a look. We're going to look at the access switch first and see what is the status of our interfaces. Our interfaces appear to be working correctly. So what I'll do here, just to be sure, I'm going to shut and unshut port channel 1, and then move on to the core switch and then see if we've got any kind of an issue. And so looking at the core switch, we can see immediately that we have a lot of errors here on the screen. Ethernet E01 and E02, which are physical interface members to the etherchannel port 2 facing the firewall. So this tells us that the link between the firewall and the core switch has not been successfully auto-negotiated, and that the firewall is perhaps overwhelming the core switch, and that's why the communication, the link is breaking down. So what I want to do is look at the firewall and specifically our aggregate interface. I'm going to try and adjust the MTU to anything below 1500 in this case. And the command there is set MTU override enable, and then set MTU to say, let's make that 1420. And then what I'll do on the core switch, I'll shut the interface and unshut it. That's port channel 2. It looks like the interfaces have come up, but let's review in any case. And our interfaces look to be working normally. And on our access switch as well, everything still looks okay. Now let's go back to our client PCs and then test. What I'll do is just bounce, turn off, and then turn back on again. Our network interfaces, turn off, and then turn them back on again, clear the screen, and then reissue the command IP address. And now we can see that we acquired an IP address in the range that we expected. And on PC2, let's do the same thing. And yes, also we have an IP address in the 210 VLAN, just like we expected. I believe this brings us to the end of topic 1.1. Join me in the next one. Until next time.